So thank you everyone for coming, especially like before lunch. So hopefully not everyone is so tired yet and there is no food coma. So today we will be talking about like how to uncover a sophisticated Kubernetes attack in real time with eBPF. So who am I? I'm a security product lead at Isovalent. Daily, I work with eBPF kernel engineers to design security features, and then basically work with like clients, customers, open source users to drive that feature towards, get their feedback, and then basically talk to engineering as well. So I like to be outside when I'm not in front of the computer, so I like running and then surfing. I also fly small planes, which is really fun. And then, so a little bit about the agenda, like what we are going to talk about today. So how can we secure application, especially on cloud-native environments? Like what are the main challenges? What is the optimal solution? What would be an optimal solution? How eBPF comes into the picture? Like what is eBPF? Why is it interesting? This is not going to be like a deep dive eBPF talk because I'm not a kernel engineer, so I couldn't even do that. And we will take a look at like one observability tool, a runtime security tool, which is Tetragon. And then I will do like two demo to example, like how could we attack, for example, container escapes and then data exfiltration. So securing application and cloud native environments. So the first question I would ask from the audience, like, how do you guys secure this? So basically, this is the CNCF landscape, like all the tools that make up the Kubernetes ecosystem. So for example, if you're like a platform engineer, a security engineer, and then you're tasked with like secure your cloud native infrastructure, you take a look at this and then you get overwhelmed. Like, where do I start? So building actually a cloud native infrastructure takes a lot of time and not even secure it. But for example, if you start with the components where you have the least trust and the most risk, it's kind of a good way to get started. So for example, if you have like a web application exposed to the internet that's and handles, for example, untrusted user input, that kind of more risky than, for example, the Kubernetes scheduler. So you can actually scan the images, the container images, but would it be enough? So don't do this. I'm not saying that scanning container images is not enough. You shouldn't put vulnerabilities into production, but you can do like additionals on top of that. So for example, you can follow KubeADM and then CIS benchmarks. This would give you like a good default for like API server, etcd, and kubelet. How can you like secure those? You could use distroless and scratch base images. So basically remove all the shell, like compilers, package managers from the containers, developer tools that the developer needs, so we don't need that. You could actually use runtime sandboxing tools like seccomp, upperm, or gvisor. So this would kind of prevent container escapes and then privilege escalations. Of course, you can do vulnerability scanning. This should be part of your build pipeline. And I didn't even touch supply chain security because that's like a whole another topic. But how can you actually measure that the protections that you are putting in place is effective? So what I'm advocating for it, we are on what the fuck is SRE, so let's make security like SRE. So security and SRE generally shares a lot of common principles, but unlike SRE, security is not data-driven yet. So we would need kind of like a data-driven approach, some kind of observability to measure like how secure we are today. So for example, we would need to collect data, observe the data, get some feedback, and then make some data-driven decisions. So we would kind of need to test our security assumptions that all the protections that we put in place that I listed before are actually effective. They are working, and then they could prevent us from real-world attacks. So I put unit testing on the left. because DevOps is using unit testing kind of to make sure that the system is secure, well understood, and then basically it's working the way it's intended. So security observability could verify those protections that you put in place in the same way. So let me explain it a little bit further. So we can take, for example, network policy. So let's say you have a pod, and then it's a web application, and then it suddenly makes, for example, an external connection, a malicious connection to the outside world on the internet. So how could you make sure that the network policy that you put in place would actually block that? So for example, if you have like network flow logs and then DNS queries, you can actually see like, was that connection actually successful? Did the network socket actually open or not? The other example would be like seccomp and uppermore. So let's say you configure those profiles, but how can you make sure that these are actually like working as the way you configured it? So for example, you could observe system calls and then file system access. So there are a lot of security monitoring tools, especially in the traditional world, that already provide observability into your distributed systems, but they are ineffective in cloud-native environments. So what are actually the problems, and then how can we bring kind of a solution to that? So those traditional network layer tools are actually based on IPs and ports. And then if you think about it, IPs and ports are not really effective and meaningful on Kubernetes anymore, because like pods are going and coming, IPs are dynamically changing. So these don't provide a meaningful identity anymore. So we would need kind of a solution, like a security monitoring tool on cloud-native environments, which would bring this identity into the Kubernetes world. So let's leave IPs and ports behind. These are not useful anymore. And then extract valuable data based on identities. And then if you would like to scale those solutions, it needs to be low overhead with almost real-time observability and kind of dynamic. And then, of course, let it easy and efficient and available to everyone so the community can use it. So how comes eBPF into the picture? So what is eBPF? Like, how many of you knows what is eBPF into this room? Okay, I have one slide to explain it, so I will be like very quick and from like a 10,000 feet view. So basically, it's a Linux kernel technology that makes the Linux kernel programmable in a secure and efficient way. And then basically what eBPF allows to do is it's actually very amazing. So you can write like a C code, compile it into a BPF code, and then load it into a kernel to different hook points, and then execute it. So basically, you could put all the user space logic inside the kernel. And then basically it's really good for overhead and then memory as well as CPU. So I put like a very stupid, simple example on the left. So basically what it's doing, it actually takes over the exec system call and then runs some BPF code and then basically returns. And then if you take a look at the code, it's just extracting some information from the process, for example, the PID, the binary, and then some com arguments. So basically, if you would load that, like it would be executed on every return of the exec system call. And then this is, for example, how application profiling and then tracing works. So I'm not sure who said that comparison. I think it was Brandon Gregg or Thomas Graf first. So what JavaScript is to the browser, it's eBPF to the Linux kernel. So basically, it allows you to dynamically load code into the Linux kernel and then makes it programmable. So how that comes into the cloud-native security observability space? So if you think about it, we could, since we are in the Linux kernel, we could extract security and then observability context from those programs, and then make that programs kind of Kubernetes aware, so you could get the Kubernetes identities. And then if you think about it, it can be done dynamically, so no need to change the application. And then it can be done at scale. So we have like users with like 10K nodes. So it's very effective actually. And they're minimally invasive when you do it with care. So why is it interesting? So it sounds really nice, but like what are the questions that we can answer with this? So I highlighted some that I will call out during the demo. So you could actually answer questions with an eBPF security tool that what binaries have run in the past and they're running now. Are we running the latest version of the library? So I am running the latest Java library that is not vulnerable, for example, a CVE. What network connections were open from my pod? Like both listening, connecting, UDP, TCP, row sockets, whatever you want to call it. Or for example, what files are being accessed, written, executed, and mapped. So the competing ideas here that it can be done real time, and then minimal CPU, and then basically no memory constraints. So the tool that I would like to use today, and then what we are working on right now, is Tetragon. So it's actually an agent, so it can run on any on the top of any Linux operating system. So in case of Kubernetes, it's actually like a daemon set, and then on bare metal VMs, it's actually like a container that mounts certain configuration files to apply like security policies to get those events outside from the kernel. So there are a lot of layers if you take a look at the pictures where we can extract data from. So starting from the low level, it's like data access, file access. We have L7 parsers, HTTP, DNS, TLS. We have visibility into namespace and then privilege changes, like kernel namespace changes. And then we have visibility into process execution and then basically any syscall activity. So all those events that I'm talking about that could provide like security observability into your system will be extracted into a log file as JSON events. And then in a real-world scenario, you could just like ship it to your CM system, like Splunk, Elasticsearch, S3, and then create signatures. And then we also have like metrics, like Prometheus and Grafana OpenTelemetry. Those are mostly the networking use cases. And then what's really important, that doesn't require any change to your application, so it can be done very differently. So what events do we actually care about? So of course I talked about like executable and syscall traces. So we could detect every running process in the system. We can detect sensitive system calls, network observability, file integrity monitoring, changing privileges, and then namespace boundaries, and then library loads. So if you think about a malicious activity that is happening on the cluster, it would do at least one of these things. So I put an example JSON event here. I'm not sure if it's really visible, but this is, for example, a network connect event. So what you can see here, the Kubernetes identity aware metadata. So for example, on the default namespace, there was a TLS weak version pod, and then it executed curl with the following arguments. And then I guess the argument it's a crypto mining pool, and then using a very weak TLS version. So these events would contain the Kubernetes API metadata, both the process and the network connection, and then some DNS-aware information. So for post-processing, what I see with our like clients and open source users, they put these events into a CM system, and then later they can do incident investigation. But like for presentations and then quick demos, I will use a CLI, and then this CLI will actually parse those JSON events and then put it into a human-readable form. So like you can actually read it, because JSON, it's really hard to read. Okay, so let's jump into demos. I will actually have two demos. I will just introduce the test environment first. And the first one will be a super simple container escape, and then the second will be stealing some sensitive information. And if the Wi-Fi works well, probably you will see it happening. All right. So for the test environment, I have a one node GK cluster. It's running 5.15 kernel version, and then the Kubernetes version is 1.25. So on that, I deployed like a super simple demo application running on the Tetragon jobs namespace. So we can see like some services here, like job posting, recruiter, loader. We have some databases like Zookeeper, we have Elasticsearch, we have Kafka here, and then crawler, which is just getting some data out from those. So Tetragon is running as a daemon set on that one node Kubernetes cluster, and then it's observing certain events that are executed on that node. So since we are in the Linux kernel, we have visibility into the node, so we could detect the host events as well as the Kubernetes events. So you will see like process execution, network connections, sensitive file access, and then one sensitive system call, which will be the sysZNS changing namespace. But if you would run like a multiple node Kubernetes cluster, so for example, it would run as a daemon set on each node, and then those events will be collected via gRPC collector. Okay, so how the first attack scenario will look like, I try to make it a bit more funny and entertaining. So I'm an attacker, and like, let's say I'm a malicious employee. I have access to a GK cluster. So as a first step, what I will do, I will just apply a privileged spot spec. So it's enabled by default in GK, and then it's actually very powerful. Not sure if it's a feature or a bug. So what I'm going to do in the pod spec, I will just set the privilege flag to true. So it will give me certain capabilities, higher privileged capabilities like sysadmin. And then I will set also two more flags to true, host PID and then basically host network. So host PID will give me access to the host PID namespace, and then host network will give me access to the host network namespace. So after that the pod is running, I can just kubectl exec into it. And then what's really amazing, I can actually enter into the target namespace, which is PID1, so it's going to be the host. And then after that, I can just enter to all the kernel namespaces and run bash. So basically at that point, I would have like a shell running as root on the host. So I would have access to all the host resources. And then I can read its password. I just put the dragon here because yeah, there should be dragons in the presentation. So I'm gonna read its password. All right, so let me just switch to the terminal. If I can do that. All right, so here we can actually see the cluster. It's going to be a one node cluster. And I also put those instructions into like an open source repository. So if someone is interested, like you can actually read it. So I'm just gonna run the commands from there. So this command is actually going to observe the events from Tetragon. So via the CLI that I was actually talking about. And then let's just monitor the privilege pod. All right, so I can actually show you the pod spec. So if you take a look at this, is just like on Nginx basic pod, and then here we can actually see the flags that I was talking about. All right, so let me just apply that pod spec. All right. And then if everything goes well, we should see the events generated by Tetragon. So I won't go through all of this, but I will just like highlight what's important. So this is like the the rocket thingy is actually the process execution, and then you can actually see the default namespace and then the privileged pod, like as the workload. And then on the purple thingy, it's actually the binary. So here we can see that we entered into the Docker entry point script, and then it just started the Nginx daemon. And then, yeah, we are using IPv6 by default, editing some configuration files, and then basically this is the process which actually starts Nginx at some point. Here we go, as a daemon. And then we can also see that it's listening on port 80, and then we can actually see that it has capsysadmin capability. So actually, like this CLI is just parsing the JSON events that I showed you before. All right, so let me just kubectl exec int. I actually described like what's going on. Let me just actually kubectl exec into that pod. So we can actually see that there was a bash executed, also like on the default namespace from the previous pod. So this is, for example, how you could audit like kubectl exec. So if you have, for example, an application team or developer teams, and then they are randomly kubectl execing into like each pod, this is how could you actually create dashboards. All right, so we are in the privileged pod. So let me just enter into all the namespaces and run bash as root. All right, so let's take a moment to appreciate what we can see here. So this is actually the process from the NSEnter binary. We can see the arguments, and then we can see that all the sys_set_ns system calls were fired. I actually printed the kernel namespaces here, so it's you could see it. And then we got the second bash, which is actually running the shell on the host. So actually, I can learn like cat proc partitions. So these are the partitions actually from the host. So we actually see that we broke the boundaries between the container and the host. And then let me just apply another policy, which would take care of the file monitoring. All right. And then let me just try to edit etc password. All right. So we can actually see here that there was a lot of open from user binv. These are the post, whatever, so it's open. And then we can say like, welcome to SRE, what the fuck is SRE? And then I can also say like, hello. Okay, and I can just save it. Great. So what we can see here, there was this syswrite system call fired. We can actually see like it's from user binv, etc password, and we can actually see how many bytes were edited. All right, so that was the first demo that I wanted to show you. And then basically, let's just go back and then do the second demo slideshow. Great. So the second attack scenario will be, let's say like I'm also like a malicious employee and I'm running this like, I'm operating this like tenant jobs namespace, and then I don't know, I just like, I have access already to the job posting up, so I have kubectl exec. So I will just start to explore around and run like M. So I discover some AWS credentials like access key and then secret key, and then I find the bucket. And then I'm just gonna see like, hey, what's inside the bucket? And then I discover like, hey, there is like a dragon picture. So I'm just gonna download the dragon picture, and then we will see like what's inside the dragon picture. So let me just go back to the second terminal, and then I will just use the command that I actually set up. So let me just start. Oops. Let me just start from the job posting up, And then let me just start observing the events from Tetragon, which I need it from, I can get it from here, I think. Yeah. All right, so now we are observing the events from the job posting up. It's communicating to another service inside the cluster, so we can see some connect and close regarding to the network socket. And let me run the environment command. So what we can see here, I can find the AWS access key, which is a good sign. And then I also found the bucket. And then at some point, I put the, yeah, here we go. I also found the secret key. So let's just check like what's inside that bucket. We already know that the dragon picture will be there. Let's just double check. All right, so I would like to actually explain like what we can see from the events. So this is actually the process event, which is coming from the user being AWS binary. You can also see the Kubernetes identity information there. And then these are all the network information like connect and close, and then transceive and then receive bytes. So we actually received some bytes, so there was information like coming back to us. All right, so let me just download that file. We can see exactly the same way the process execution, some connect and close events. We can see that we received bytes, so there was actually like data coming in, and then we can actually see the exit, so the command was successful, and the red zero is actually the exit code, so we know that it was successful. All right, so yeah, let's see the dragon picture. Great. So I try to make it funny. Let's switch back to the slides. So basically wrapping up, what I wanted to say here, like, how can you actually measure that the protection you put in place, for example, network policies, seccomp, UPAR, more gvisor, whatever you want to call it, you actually require security observability. And then you would kind of need a solution which is like low overhead, real time, and then dynamic. And then, of course, it was just like a small funny talk, but like actually big customers and clients, open source users are using it, mostly like telecommunication companies, trading platforms, banks. And then, yeah, I showed a quick demo on like 2 examples, like how can you detect attacks quickly. All right, so if you would like to like get involved in the community, so go to the GitHub repository. We are nice people, like use the tools. We have bugs. So report bugs, feature requests, tell your experience. And then it's not, what I wanted to call out also, it's not only eBPF coding. So you don't need like eBPF and kernel knowledge to actually contribute. We can have like, or we have, for example, Go user space agent with many minimal knowledge, and then also like documentation, packaging, and so on. And then if you're interested more, so I actually wrote like a book about it. It's very like beginner and then user-friendly. So it also includes like an attack and then an introduction to eBPF, like how could you actually use eBPF for detect those kind of attacks. So there will be a book signing just in 2 or 3 minutes on the Isovirant booth during lunch. So come and say hi. And then, yeah, thank you for coming. And